Hello, so in today's lesson we're going to begin our study of polynomial expressions. So today our learning target is I can identify parts of an expression including terms, factors, and coefficients. So today is in large part going to be a lesson in vocabulary, and we're going to learn several different terms that will help us classify and analyze polynomial expressions. So first off, we want to discuss what is a polynomial. So a polynomial is any mathematical expression of the form ax to the b plus cx to the d plus ex to the f, and so on. So our first vocabulary word is term. So the terms of a polynomial expression are each of these, for lack of a better word, things that we add together. So these are all what we call terms. So to count the number of terms of a polynomial, you would just count how many of these things there are. So for example, if an example of a polynomial could be 3x cubed plus 2x plus 5. So how many terms are there in this expression? There is 1, 2, 3. So that is how you identify how many terms are in a polynomial expression, is you just would count each of these. So now we want to look at next what the degree of a function is. So the degree is the highest exponent in a polynomial. So the exponents are these numbers, so it would be like b, d, and f in this case. And in this example, our exponents are 3, 1, and then this is what we call a constant term, and this would have an exponent of 0, because if we wanted to, we could imagine that there's a term x to the 0th, which any any number to the 0th power is equal to 1, so that's why we just got 5. So that's a little aside there. But to identify the degree of a polynomial, we just want to look at these exponent numbers and see which is the highest one. So in this case, our degree would be 3. So I'll draw a little arrow and write degree. So let's look at another example. Suppose we have 6x to the 7th minus 5x to the 6th plus 3x cubed plus 91x. So how many terms are in this polynomial expression? There is 1, 2, 3, 4. So we have 4 terms. And now let's see, what are our exponents? So we have 7, 6, 3, and 1. So we just look at which of the exponents is the highest. So if you look, you'll see that 7 happens to be the highest. So we would have a degree of 7. So you do have to be careful in that you will get examples where the term with the highest exponent is not listed first. Like for example, we might have an example where we have 2x squared plus 9x minus 8x to the 4th plus 3. That's still a polynomial expression, but you see the degree, the highest exponent, is 4. So 4 would be our degree. And then one last component of a polynomial expression is the coefficient. So the coefficient of a polynomial expression would be the a, the b, and the e. So these would collectively be known as our coefficient. And the definition of a coefficient would be the constant term in front of a variable in an expression. So each term will have its own constant. So in this example, the constant for this term would be 3. Constant for this term would be 2. The constant for this term would be 5. So our constants are 3, 2, and 5. You can also have negative constants. So here we have this constant is 6. This constant is negative 5. This constant is 3. And this constant is 91. And then again in this case, this constant is 2. This constant is 9. This constant is negative 8. And this constant is 3. Additionally, if a term, suppose we have the polynomial, so 8 x squared plus x minus 6, the constant of this term would be 1, because we could imagine that there's a 1 here. And then our last vocabulary term, which is kind of piggybacking off of coefficient, is our leading coefficient. So our leading coefficient is the coefficient of the term with the highest exponent. So let's go back and identify what the leading coefficient for each of these terms is. So in this case, first we want to identify which is our term that has the highest exponent. So it's 3x cubed. So that would mean that our leading coefficient is 3. So I'll write LC is 3. In this example, our term that has the highest exponent is this. So our leading coefficient is 6. And then in this example, again we discussed earlier, sometimes the highest exponent is not at the front. Our term with the highest exponent is here. So our leading coefficient would be negative 8 in this case. So this is the basic vocabulary for polynomial expressions. So let's just do one or two quick examples of what you might see on one of our quizzes or worksheets. So you'll see there are lots of varieties of polynomials. In fact, an infinite number of possible polynomials. So suppose we have 3x to the 5th cubed minus 8x squared plus 102. So how many terms are in this expression? We have 1, 2, 3, 4. So terms would be 4. What's our degree? So again, for our degree, we want to look at what the highest exponent is. And that would be 5. So our degree is 5. And then our leading coefficient, we want to look at the coefficient that is in front of the term that has the highest exponent. So this term has an exponent of 5, this term has an exponent of 3, this one has an exponent of 2, and this one has an exponent of 0. So what that means is that -3 is our leading coefficient, because it precedes the term of the highest order. We're just going to do one more really quick example. Suppose we have -37 plus x squared plus 18, well, let's do plus 18x to the 20th. So this example, how many terms do we have? We have 1, 2, 3. So terms, we have 3. Our degree is the highest exponent. This has an exponent of 0 since there's no x. This has an exponent of 2, and this has an exponent of 20. So 20 is our highest exponent, and our leading coefficient is the coefficient of the term with the highest exponent, so that would be 18. So that concludes our lesson on kind of identifying the components of an expression. And in our next lesson, we'll look into adding and subtracting these polynomial expressions. So stay tuned for that.